Hello everyone, my name is Teveshwar Naidu and I am pursuing BTech CSC specialized in Artificial Intelligence and Data Engineering in Lovely Professional University. I'm here to discuss about what is binary tree and operations in binary tree such as insert and delete with uh, traversal techniques. So in traversal, we are going to discuss about in order, pre-order and post-order, and also we are going to implement the code in Python at the end. So Introduction to binary tree. So binary tree are fundamental data structures in computer science and are widely used for analyzing and organizing, also managing data efficiently. A binary tree is a hierarchical structure composed of nodes, which uh, where each node has at most two children, referred to left child and right child. The topmost node is called the root, and the nodes which are below are divided into levels. Each node contains a value and pointed to the left and right children. So in binary, so in binary tree structure, we will have different types of nodes. Firstly, root node, where it is the topmost node, and we also have the parent node, which is a basic notation. Says a node which which has a child node, and of course a child node which is the parent, and after that we also have leaf node, a node which has no children. You can find leaf nodes in the ending of the tree, and after that you will have internal nodes which will have the parent and also children. And so these are the important nodes in binary tree. So to represent this all, we're going to draw a normal tree. So this is the root node, and if we go on, assume it has two children. So these are the internal nodes. So here you can see we started with a root node, which is the topmost node. Then we have the root has two children, which are internal because it has at least one child. And so a root can have a left child and right child. And here we can see root nodes. So root nodes will have no children, and every node must have at most two children. So here you can see the internal has one, and this internal node has two. And the number of nodes of each parent should not exceed two. And we can apply, we can implement this binary tree using linked list and array. But the case in array is if there is space where you can see here, this internal node has only one child. If we implement this in array, one of the data space will be empty, which will have none value. And if we move on, so now we are going to discuss about the operations in binary tree. We are starting with insert operation. So we are going to add a new node to the tree while maintaining the binary tree properties. So we are going to add a node considering the root node and the other nodes. So imagine the value, let's assume the value of root node is something 5 and consider this as 3 and let this be 7 and let it be 2 and this be 8 and let this be 6. And so here you can see the internal node, which is the left child of root, must be less than the root. So here, this internal node, which has value 7, is greater than the root node. So it's placed at the right right child data place. So here you can see the leaf node, which has value 2 and which is less than 5. So we're going to place at the left subtree, and we're going to consider this left subtree where this internal node becomes root, and we're going to compare 2 with this internal node, and 2 is less than this internal node, which is root of this subtree. So we are going to place 2 at the left side of left child of this internal node. So we place 2 here, and you can see 6 here. So 6 is greater than the root node. So we are going to the right subtree of the main root, which is the topmost node. So here 6 is less than 7, so we are going to place it to the left side of internal node, this internal node, and you can consider 8. 8 is greater than 5, so we are moving to the right subtree, and 8 is also greater than 7, which is the root of this subtree. So we are going to place at the right side of this internal node. So we placed 8 here. So these are the leaf nodes because it does not have any more children. So if you want to insert any other value, so consider taking 4. So initial step of inserting operation is to create a node. So we are going to create a node. So let's consider a node which has value 4. So here initially we need to compare this node to the root of the tree, root of this binary tree. So 4 is less than 5. So we are moving to the left side of the tree. So we are moving to this left subtree where 3 is the root. So we are going to compare 4 with 3. So of course 4 is greater than 3. So we are going to the right side. So we are going to place this node to the right side of 3. So let me place Hmm. So here we're going to place it here. So here we can see we inserted a node which has a value 4 uh, by comparing it with the nodes, the present nodes in the tree. So here is the property we're following. We are going to compare the new node with the root. If it's greater than the root, then we are going to the right subtree, and if it's less than the root, we are going to the left subtree. So this is how the insert operation works in binary tree. And and if we go for the delete operation, so if we want to delete a particular node, or else we can, if we want to delete a node which has value, so consider deleting 6. So if we want to delete 6, let me right here. So delete operation. Let's delete a node which consists of 6, value 6. So we're going to delete this node. So consider taking 6. So firstly, we need to compare 6 with the root node. So 6 is of course greater than the root node which has value 5. So we are moving to the right subtree, and we are comparing 6 with this right subtree, where this internal node is the root of this right subtree. So 6 is less than or greater than. We need to uh, check whether the 6 is less than or greater than this root. So 6 is less than 7, so we are moving to the left side. While we are moving, we need to also check whether the root is equal to the value which we are going to delete. If it's equal to the value which we are going to delete, then we can perform the delete function there itself. So 6 is less than 7. So we are moving to the left side. So finally we found the 6. So here, so we are going to delete this connection between the internal node and the leaf node. So we can get rid of this leaf node 6, which consists of value 6. This is how we are going to uh, perform operation delete. So if we discuss about how this works, so consider a node which will have 3 data fields. So here these rectangles representing each of the data fields. So consider the middle one has data, like the value of the node, and the left side will have the left child's address, and the right side of this node will have the right child's address, of course. So this is a normal node. Uh, the normal node can be a root node, or can be an internal node, or can be a leaf node, considering the values which has in its left and right address fields. So if it's a root node, so here consider this root node. You can see here it has data 5, and if we assume that this internal node has something address 1001, and this has 1002. So the root node, which is pointing to the left and the right children, which has 0.1002 and 001001 as its address fields. We're going to write the address fields here. So it has 1002, and so this is how it will store the address of the left and right child with also its value. So this is a normal representation of a node. So now we discussed about what is binary tree, and also we discussed about the different types of nodes in binary tree, and we also discussed about the insert and the delete operation. Now it's time for the traversal. So traversal refers to the process of visiting all the nodes in a tree. There are three common traversal techniques. If you want to go further, let the first traversal technique be in order. In order traversal, where we are visiting the left child, uh, visiting the left subtree, then the root. At the end, finally, we are visiting the right subtree. So you can simply write left left subtree, then root, the topmost element of the tree, then right subtree. So this is in order traversal, and let the second traversal be pre-order, where the root will be visited first, and that will go with the left subtree, then finally right subtree. So root, then we will visit the left subtree. After that, in the end, we will visit the right subtree. And the third and the last traversal technique is post post order traversal. So in the post order traversal, the root node will be visited in the ending. So we will be starting with the left subtree. After that, we will visit the right subtree. Finally, we will visit the root. So these are the commonly used the three traversal techniques. So if you um, so consider this tree which we drew. So here root node, internal nodes, and the leaf nodes. You can see these all nodes here. So first we are here to implement in order. In order, first we will implement the in order traversal method technique, and then we will implement the remaining traversal techniques. So here we will visit root node. We will visit the left subtree, left, then root, and in the ending we will visit the right subtree. So you can see here. First, we will visit the left subtree. So this is the left subtree. So here, this is again, if we go with the left subtree, so this is the root, and so we will again go with the left subtree. So finally, we reach the end of the le left subtree. So this is the left subtree. So we will have 2. Then after uh, after reaching the left subtree, the ending of the left subtree, we need to go through the root node, which is internal node, which has a value of 3. So we will have we will have 3, and after 3, so we traversed through the left node, then we went through the root node, and finally we are going to reach the right node or right subtree. So here is the right node, which has value of 4. So we'll have 4 here, and after completing the left subtree, so here is our root, which has value 5. So we will have 5 here. You can see here. We have completed traversal through the left subtree, so we are at the right subtree. So after having right here the root, finally we're going to the right subtree. So here you can see the root of the right subtree is internal root, which has value of 7 and address of 1001, which we used in the previous example. So here we have reached through the right subtree. So again, we need to apply this in order property. We need to go with the left subtree again. So there is a leaf node, and the leaf node which has a value 6. So we will write 6 here. After this, after passing through 6, we again need to go to the root node as we traverse it to the left part. After that root, so the root of this right subtree has value 7. So we will write 7 here, and we will reach the right part as we reach the left part. The remaining part is the right subtree. So here right is a leaf node, which is not a subtree apparently. So here, so here you can see. Here we have performed the in-order traversal technique where the output is already sorted. So this is the benefit of the in-order traversal technique in binary tree, where we will follow a property where we compare the insert node with the root and with the root node. If the insert the new node is less than the root node, then we will place in the left subtree, and if it's greater than the root node, then we will place in the right subtree. Because of that, we have a sorted traversal method, which is in order traversal. So we have completed in order traversal now. So we are going to perform pre-order and post-order too. So let's do pre-order traversal. In pre-order traversal method, we will visit root. We will visit root in the we will firstly visit root, then we'll go with the left subtree, then we will visit the right subtree at the end. So here you can see, here is the root. So this is the root. As you can see, the topmost node of the tree. So we will first visit the root node. After that, we're going to the left side, left subtree. So this is the left subtree. So you can see here, this is a left subtree, and left subtree also has a root node, which is internal node, which is the root node of the left subtree. So which has an address field of 1002. So again, we need to apply the pre-order traversal technique. So firstly, we will reach to visit the root node, which has value mm, value 3, which is value 3. So firstly, we will reach the root node 3. After that, we're going to reach the left side of the root, which has value of 2. So we'll go through the 2, and after that, we are going to reach the right subtree, which is value, which is a leaf node and which has value 4. And as we completed the root node, then we went through the left subtree. We also completed visiting the left subtree. So the remaining one is the right subtree. So consider right subtree, which you can observe has 3 nodes, and we need to apply the pre-order traversal technique on the right subtree. So starting with the root, which has value 7, following the pre-order technique, we will go with the left node. So which is a leaf node. So we are going to directly write the value in the leaf node. And after reaching the left, we are going to reach the right, so which has value 8. So here you can see the pre-order traversal where the sequence will be 8, 3, 2, 4, 7, 6, 8. Oh, sorry, this is 5. So this is a pre-order traversal technique. The the final traversal technique is the post-order traversal technique, where we will follow uh, sequence with left subtree, then we'll go with the right subtree, and finally we will visit the root node. So the final technique is the post order, where we will visit left subtree firstly, then we'll visit the right, then we will finally visit the root node. So this is the property of post order traversal technique. So if we go through the tree, firstly, we need to go through the left of this root. So this is the left subtree of the root. So here you can see this is the left subtree. And again, in the left subtree, the internal node will become the root node. And again, we need to follow the post order property. We need to go with the left child again. So left child is a root node. So we are directly going to write the value in the left child, which is 2. So we have completed the left subtree of the main root node's left subtree. So here we have completed this one. So we need to go through the right subtree of this internal node, which has value 4. So we'll just write the 4 here. And after going through the left and right, we finally need to go through the root node of this left subtree, which has value 3. So here I wrote 3. After completing the left subtree of the main root, we are going to visit the right subtree. Right subtree. And again, we need to apply the post order property where we will go through the go to the left, so which has value 6. After completing the left one, we're going to the right subtree of this internal node, which has value 8. Now, after completing the right node, we are going to the root node, which has value 7. Now we have completed the left subtree and the right subtree of the main root of this tree, which is value 5. As we completed the left and right, we need to visit the main root node. So main root node has value 5. So this is the sequence of post-order traversal technique, where the order will be 2, 4, 3, 6, 8, 7, 5. So these are the three techniques which are commonly used as traversal techniques in binary tree. So as for now, we have completed what is binary tree and operations in binary tree, which are insert, delete, and traversal, and in the three different basic types of traversal, which are in order, pre-order, and post-order. And finally, we are going to implement the code. We are going to implement the binary tree code in Python using Google Colab. So we are going to implement the binary tree and its operations with traversal techniques using Python. So we're using Google Colab for Google Colab Python notebook. So we are starting with creating a class for the tree node. So this class is used to create a new node. And so here I'm using a constructor with self as current object and with key. And as we discussed previously, a node will consist of two address fields and one data field. So here is the left one with none value and the right with none value. And finally the data field, let it be value or val, which stores the key which have taken from the user. And here is a definition for the insert operation. So we'll have two parameters. One is root and the other one is key. Key is the one we are going to insert in the tree which has the root, which has a root. So here if the root is none, we will just return the tree node with the present key value. Else, we will run an if else conditional statement. If the key value is less than the root value, we'll follow the property of binary tree, where we're going to insert in the left subtree as the key value is less than the root value. So we will use the insert function again here with root parameter with root dot left and with the same key value. And if the key value is greater than the root value, we are going to insert at the right subtree. So there is an else conditional statement where the root dot right, we are reaching to the right side of the tree and we are inserting in the right subtree with first parameter root dot right and the second will be the same previous key value, and finally we will return the root. So we have completed the insert function. So here is the delete function where we will take root and key key is the value we are going to delete in the tree. So from here, so this is insert function with parameters root and key value, and this is the left child of the node, and this is the right child of the node. This is the data field. Here we go on. So in the data, in the delete operation, if the root is none, where the tree is empty, we will just return the root as it's empty. And if it's not empty, we are going to the next line of the code where we will run an if-else conditional statement. If key is less than if key is less than uh, the root value, the root dot left. If the key value is less than the root value, we are going to the left subtree to find out the key node, and we are going to delete. So we're moving to the left subtree, and again we are calling the delete function. We will change the root parameter into root dot left, and we will keep the key value as same as before. And elif key value is greater than, and if key value is greater than the root value, then we will go through the right subtree and we will find out the key a node which has key value, and we are going to the right subtree. Mm, and we will call the delete function one more time, where the root parameter is changed to root dot right, and key value will remain same. Uh, if the above three statements are false, then we will finally get the key value which is equal to the present node's value. So we will finally perform the delete operation here. So we will start with the if conditional statement. If the left is none, we will take a variable which will store a temporary address field of the root node, and we will take root as none. Then we will finally return the temporary variable which consists of the root dot right, and if the root dot left is not none but root dot right is none, and the root dot right is none, we will again take a temporary variable which we require to store the root dot left address field's value, and we will take the root as none, and we will return the temporary variable. So after this if else conditional statement, we are will take the temporary as minimum value value node which has which will give an argument row dot right. We will create a function which named as minimum value node, which will give us the least valued node in our binary tree. We're going to create this function after creating a delete function. So consider this main value node as a node which consists of the least valued element. So after this, we will rewrite root value with temporary variables value, and again we will take root dot right subtree of the root, and we will perform delete operation with parameters root dot right subtree and the temporary value. So finally we will return the root. So this is the definition of the function delete. So here are the comments which will help the people to understand our code. So here we have wrote the comment for the delete definition. So this is the definition of the delete operation with parameters root and the key value. And this is for the root if it's empty, then it says the tree is also empty. And we also have here where we are checking the property of the binary search tree where the key value is less than the root value, then we will visit or then we'll go through the left subtree, and and if it's greater than the root value, then we will go through the right subtree, and also we'll find then in this else additional statement, we're finding the root with the key value. So that's what I'm writing here using comments. So this is the definition of the delete function. And after that, as I discussed before, we are making a function which is named the main value node, where we'll find the node which has the least value. So using the property that we have discussed before, uh, the least nodes will be always placed in the left subtree. As we are comparing the root node, we will go through the left. So I will write a definition for min value node. So here I will take a current variable holding the data of the node which I gave. So while the current left is not none. So as we taken a current variable because Here we are going to change the current the node value. We are going through the left subtree. So the current value will be constantly changed. We'll be going through the left. It's similar to the linked list, finding the last element in a linked list. So finally, when we reach the least node, which is placed in the left subtree's leaf child, like left leaf child. So here we are returning the least valued node. So if we go through this min value node again, so this is a function to return the min value in the tree, and this is a current node which will change. So this while loop is used to continuously visit and go through the last node of a last node in the left subtree, which is the least, using the principles of a binary tree. So this is used to reach the leftmost leaf node. So finally, we will return the least value node. You can say that. So this is the definition for uh, minimum value node, where we will return the minimum value node. So after that, we're going through the traversal methods. Firstly, we'll start with the in-order traversal. So in order traversal, we will have in one parameter, which is the root of the binary tree. If root, which says if root is not none, we will perform in order. Like we will apply the same in order principle to the left child, left subtree. Then we will print the right. Uh, like when we'll print the root node's value. After going to the root node, finally we will go through the left subtree, root dot left. So this is a recursion where the in order definition, which we'll call the definition itself, and this will perform recursively until we will reach the last leaf node. So then we will print the root node's value, root node of the subtree, and this. So this is the in order where we will go through leaf, then root, finally the right subtree. So after this, we will go with the reorder. Again, we will go through the if we will check whether the tree exists or not by just running an if conditional statement, checking whether root is none or not none. So again, in pre-order, we will go through the root node. Firstly, we will go through the root node's value, then we will go with the left subtree, and finally we'll go with the right subtree. So first we will print the root value, then we will use recursion and go through the left left subtree of the root, then We'll again use the same property of preorder, and we'll go with the right subtree. So this is the definition of preorder. So first we will go through the root, then we'll go with the left, and finally we'll go with the right. So this is the definition of preorder, and the final traversal method is post order, which we will take one parameter root. So post order follows left, right, and finally the root principal. And we will again check whether the root is empty or not with an if conditional statement. And firstly, we'll go with the left subtree using recursion. And after left subtree, we will go through the right subtree, and finally we'll print the root value. As we followed left subtree, then we'll go visiting the right subtree. Finally, we visit the root. So these are the operations and the basics of a binary tree. So before we perform, so finally the server got connected. So we're going to run this whole code. So the whole code got executed. So we will start testing this code. So we will start with the root node. Let's give its value none, and after that we'll insert by using insert function root, and we will give value 50. It will be 50, and again we will insert another root, insert another value by using insert operation, by using root parameter with value 30. Let me insert multiple nodes which will consist of different values. Let it be 20, and let this be 40, and let this be 70. And let this be 60, and let this be 80. So you can see here we have wrote the code to insert 7 nodes. We start with the root, uh, taking its value as none. So let's run this. So this got executed, the whole code got executed. So let's write a statement, print statement saying in order traversal. We will call the function in order which we have written code before. Let's give its parameter root. So here We will run this code again as I made a small change in this definition. In order, we have written root dot left here where we need to write root dot right. So we will run the code again. So here you can see the whole inputs got sorted. It started with a 20, 30, 40, 50, 60, 70, 80. So if we want to get the whole thing in one line, we will use an formatting, and so you'll get the whole in order traversal in one line. Oh, not here. We will write in the function itself. So in the print statement here, we will use an end formatting where the code will give us uh, the in order traversal in one single line. And if we go on, we'll again use print statement to print the pre-order traversal. So we'll call the function pre-order, and we will give a parameter root. So this is pre-order traversal will perform. Mm, So here you can see 50, 30, 20, 40, 70, 60, 80, where the root, so the root of this tree is 50 as we inserted 50 firstly. So it will be the root. So in the pre-order, the root will be visited uh, in the first place. So we printed 50, and if you want to get this output in one single line, we'll use formatting, and in the similarly in the post order too, we'll use formatting and get the output in a single line. So let's go through the post order traversal. We'll give its argument root. So we will run this code. So you can see this. And the 50 is the root as we discussed. 50 is the root of the tree, and it's in the ending. And here the 50 is in the middle, and in the pre-order, 50 is in the beginning. So these are the three traversal techniques that we have discussed. And this is how we insert, just using an insert function. And if we want to delete, let's write delete function here itself. So we'll just directly use the delete function. We'll call delete, and then we'll give the root. After giving a root parameter, we will decide a key to delete. Let's delete 20. So we will write 20 here. As in the definition, there are two arguments. One is the root of the tree, and the other one is the key value which we are going to delete. So I wrote here 20. So let's check it by running the code. So here you can see in order the 20 will be deleted, and we got 30, 40, 50, 60, 70, 80, and here also in the pre-order we have we can't see 20 here as the 20 is deleted. And if we want to delete one more thing, let's delete 70. So in the delete function, we'll give one parameter root, and the other one is the value which we are going to delete, and let's delete 70. So here you can see 70, but after running the code, we can't see 70 as it's deleted. So here you can't see 70 or 20. So both 20 and 70 are deleted. So this is how we insert, uh, insert and delete delete in the binary tree. And also these are the tree traversal techniques which we will use to visit each and every node in a binary tree. So this is the whole code of the operations in the binary tree and also the class to create a node. So thank you. So